Some important properties of Pearson's product moment correlation coefficient are as follows. It is a pure number. It is symmetric Ryx equals to Rxy. It is independent of any shift of origin or any change of scale. If the values lie between -0.5 to 0.5, it's case of weak correlation. Values from +0.5 to +1 indicates moderately strong positive correlation, and that ranging from -0.5 to -1 indicates moderately strong negative correlation. Now we will discuss about the mathematical representation of the product moment correlation coefficient.
So the original values were xi and yi, I running from 1 to n. Now suppose the values are shifted, such as xi minus x bar, and this yi prime becomes yi minus y bar. So okay, I take them this as x minus x bar and this as y minus y bar. So originally this was the case, and now because of the shift this becomes the origin x bar comma y bar, and these are the new labeling of the axis. Okay, xi prime and yi prime. Okay, now if the thing is that most of the values lie like this, that means in the first and the third quadrant. So what does that mean? That means that summation of xi prime yi prime will be positive. And suppose the values are oriented like this, most of the values, then what can you say? Summation of xi prime yi prime will be less than 0. And suppose they are evenly distributed, we can say it's a case of zero correlation. So now we could have said that the coefficient would have been but this has some drawback. The first drawback is that because of the units we cannot choose this as the coefficient, and second is the case of variability. So to remove these two problems, what we do is we divide this by n and divide the whole thing by standard deviation of x multiplied by standard deviation of y. So basically this is root over of variance x, and sy is the root over of variance y, and the numerator is the covariance of x and y. So we get the formula as we discussed before. Okay, thanks for watching.